Good morning. Today we're going to look at a mixture of rules problem. This will actually be called the chain quotient rule problem. So let's write down our function at hand. So let's consider f of x is equal to 3x minus 5x squared plus 1 over sine x, all raised to the fourth power. Now, certainly this is a chain rule problem because we have a non-trivial inside function. And the reason we call it chain quotient, that's in a way we say it this way. This is the order in which we will apply the rules. It's not quotient first then chain. It's chain first because we don't do the quotient rule until we're completing the chain rule, namely where we're doing the derivative of the inside function. You'll see this when I illustrate the technique. Okay. So the outer function, of course, is the function x to the 4. So let's apply the chain rule. We apply the outer rule first. So the 4 comes down. We recopy the inside. 3x minus 5x squared plus 1. Notice no quotient rule is happening yet. We're still in the middle of the derivative of the outer function. Now what do I do to the exponent of 4? Well, of course, you decrease it by 1 is 3. Now we're beginning to complete the chain. So the chain rule is now, what am I going to put here? Well, I'm going to put the derivative of that inside function. And the inside function is the quotient. So this is where the quotient rule comes in. So we'll do this with the quotient rule. And when I'm done, I'm probably, depending on how it looks in the space that's left, I'm probably not going to simplify the result. I'm just illustrating the technique. All right. So now we're doing the derivative of the inside function, which is a quotient rule. That's the derivative of the numerator. Times the denominator. Minus, that's part of the quotient rule, the derivative of the denominator times the numerator. Okay, now that completes the numerator part of the quotient rule. Now remember, the quotient rule, you don't forget it, we always take the denominator squared. And that's really, the derivative is complete at this time. I don't see the need for simplification. In fact, really, it doesn't really simplify that much. Now, of course, sine squared, you could make this sine cubed and get sine to the 5th, but I'll say it's fairly simplified at this point, certainly for demonstration purposes. So let's review. So inside here, when it came time to do the derivative of the inside, I had to use a quotient rule. And notice I didn't have any other rules to do, okay? When doing the quotient rule, if this had been sine 2x, for example, then I would have recopied that here. But how do you do the derivative of sine 2x? That's another chain rule, right? You would have another inside function there. So in that case, it'd be chain quotient chain. But this was a simple problem. Looks fairly complex, I know, but simple in terms of the two nested rules, chain quotient rule computation. Thank you.